Welcome to the channel. In this video, we will discuss one of the elements of Mikrotik router protection, namely the ICMP protocol. In order to somewhat understand this protocol, I'll have to lay out some boring theory for you, but unfortunately, we can't do without it, so I hope you won't hate me too much for it in this video. So, what is ICMP, Internet Control Message Protocol? It's a network protocol that is part of the TCP/IP protocol suite. ICMP is mainly used to transmit messages about errors and other situations that occur during data transmission. For example, when a requested host or router doesn't respond. Where is this used in practice? For example, you're all familiar with ping, which is used to check the possibility of delivering IP packets, using ICMP messages with type 8, or traceroute, which displays the path of IP packets, also using ICMP messages with type 11. Summing up all of the above, a logical question arises. What makes this protocol, or more precisely, the use of the protocol, so dangerous? Although some IT specialists are skeptical about this, there are still certain types of attacks that use this protocol, such as Smurf attack. In this attack, attackers send a large volume of ICMP echo request messages to a broadcast IP address, using a fake address as the source, the victim's address. All devices on the network responding to these requests send replies, ICMP echo reply, to the victim's address, increasing the traffic to it and the possibility of overload. Ping of death. In this attack, attackers create a fake or very large ICMP echo request packet that exceeds the maximum allowable packet size for the operating system or network device. The aim of this attack is to hang or crash the victim device due to incorrect processing of the received packet. ICMP flood. In this type of attack, attackers send a large number of ICMP echo request messages to a network device or computer to overload its network stack or computational resources, which may result in denial of service. ICMP redirect attack. In this attack, attackers send fake ICMP redirect messages to computers on the network to redirect their routes to a node controlled by the attacker. This can lead to traffic redirection through nodes controlled by attackers, where they can intercept data or perform other types of attacks. So how can we protect our router? It's relatively simple. We can allow only specific ICMP requests to our router, and deny all others. Let's move on to practice. First, I'll create rules, and then I'll briefly explain what they do. Now let's understand what all these rules do. These rules in Mikrotik set up ICMP packet filtering on the router. All these rules, except the last one, indicate that packets of this type will be accepted. The last rule denies all others. Why do we allow these specific types? Because these rules are considered safe or useful for the proper operation of the network. To make it clearer, let's go through each one. Echo reply, 0:0. This type of ICMP packet is used to respond to ICMP echo requests, which is part of the protocol's functioning. Destination network unreachable, 3:0. This packet indicates that the network the device is trying to reach is unreachable. It's allowed for routing error handling. Destination host unreachable, 3:1. This packet indicates that a specific host on the network is unreachable. It's also allowed for routing error handling. Host unreachable, fragmentation needed and DF set, 3:4. This packet indicates that fragmentation is needed, but fragmentation is prohibited, DF set. It's allowed for routing error handling. Echo request, 8:0. This type of ICMP packet is used for echo requests, often used for network diagnostics. Time exceeded, 11:0. This packet indicates that the time to live, TTL, for the packet has reached 0. It's used for detecting routing problems. Parameter problem, 12:0. This packet indicates that there are parameter errors in the IP header of the packet. This may include incorrect header length or incorrect parameters. Drop all other ICMP types. This is a general rule to drop all other ICMP packet types that don't match any of the above rules. So, these rules only allow certain types of ICMP packets that are important for the correct operation of the network and diagnostics of problems, while other types of packets are dropped to ensure network security. I'm sure many of you have questions about what these ICMP packet types are. Let's delve into what ICMP packet types mean in detail. In the ICMP protocol, there is a hierarchical structure of messages, which includes types and subtypes. Let's take a closer look at these terms. ICMP type indicates the general category of the message. This is the first byte in an ICMP packet. ICMP code or subtype details the specific message type. This is the second byte in an ICMP packet. The type and subtype together identify the specific type of ICMP message and help systems and routers handle these messages correctly. The combination of type and subtype determines what action needs to be taken with this message. Thus, in ICMP filtering rules, the numbers are separated by a colon, 3-4, to determine the specific type and subtype of ICMP message to be processed by this rule. A detailed list of ICMP types, as well as the original configuration rules, can be viewed at the links that I'll leave in the video description. That's all from me. Goodbye.